Hey class, in today's lesson we are going to discuss polynomials, linear factors, and zeros, which is found in section 5-2 part 2 of your book. We're going to analyze the factor form of a polynomial and identify relative maximums and minimums. So something we need to talk about is multiplicity, and we find multiplicity when it's basically the zero of a factor. And so when you have repeated zeros, it states the multiplicity, and so it tells your graph, or it tells you what the graph is doing at that zero. So we'll kind of see what that means in just a moment. So in example 4, it says, what are the zeros of the function below? What are their multiplicity, and how does the graph behave at these zeros? All right, so to find the zeros, we need to factor first. So in order to factor, we need to find the greatest common factor. So the greatest common factor here is x squared. So if I take out x squared, I'm left with x squared minus 2x minus 8. If we do AC from there, AC is going to give us negative 8. And if I factor from there, the ones that are going to give me negative 2 are 2 and 4, specifically positive 2 and negative 4. So if I keep going, that's x squared, and then x squared plus 2x plus minus 4x minus 8. Okay, group and group. X squared is still out. If I take the greatest common factor of the first part, that's x. What's left over is x plus 2. And then minus 4, and that's also going to be x plus 2. So my factors are x squared times x plus 2 and x minus 4. And you need to understand that x squared is actually a factor. And what that factor is x plus 0 squared, or you can say x minus 0 squared. So I'm going to replace x squared with x plus 0 squared. So my zeros are x equal to 0, x equal to negative 2, right? Because I had to set that equal to 0. And the other one is x equal to 4. So the multiplicity here, so if I do the multiplicities right below, the multiplicity of the first one is 2, then 1, then 1. So what it means is that 0, it's going to behave quadratically, and the other two are linear at those points. And so I believe I can get this to show us the graph right behind it. So let me see if I can do that. And so that kind of doesn't help. So let me see if I can erase at the same time. Get some, apparently I can't erase, but I am correct. So at the 0, and I'll kind of use a different color. I'm going to use purple. So at the 0, which is 0, and I didn't mean to use the highlighter, but oh well. You can see that the graph is quadratic there, right? It's curving. At the 0, negative 2, which is right beside it, so right here, right, that's linear. It's going straight through. And the same thing for 4. 4 was another one of my zeros, and it is linear through that point. So finding multiplicity kind of helps us see how the graph behaves at those zeros. Okay, something else that would have been helpful for us if we wanted to know a little bit more about the graph, don't forget, is turning points. And so the highest power here was 4th power, so it describes that there should be 3 turning points, and there are, right? There's one right here, one right there, and there's one way down there, but we can't see it on this graph. All right, so let's look at the next problem. All right, so again, what are the zeros? So to be able to do that, we need to find the greatest common factor, which is x. We're left with x squared minus 4x plus 4. AC would give us 4, and the factors of 4 that work are 1 and 4. Specifically, hold on. Actually, 1 and 4 does not work. Sorry. 1 and 4 does not work. It's going to be 2 and 2. And how 2 and 2 work is -2 and -2. So here we go. X, then x squared minus 2x minus 2x plus 4. If I group them, x is still out. That is x and then x minus 2. And then -2 and x minus 2. So our factors are x, x minus 2, and x minus 2. So our zeros would then be x equals 0, x equals 2. Their multiplicity, there's 1 0 as a 0, and then there are 2 2's as zeros. So there we go. And then so the behavior is linear here at 0, yeah, and then it's quadratic at 2. And so to describe further what I was talking about, in the background is our graph. So once again, at 0, like I mentioned, at 0 it's linear, right? It's a straight line at 0. At 2, it's quadratic, it's curved. And so that describes the 2 zeros of our graph. And once again, if I wanted to talk about the turning points, we have our highest power is 3, so that means that there should be 2 turning points, and there are, because there's one right here and there's one right there. All right, so a little bit more vocabulary. So at those turning points, remember when it was quadratic, we only had a maximum or a minimum? Well, since you are dealing with more than one curve, those aren't considered just regular max and min. They're considered relative max and relative min because there may be more than just 2 humps, for example. There may be 3. So if you're talking about max, I need to talk about, as far as relative max, what is the highest of the maxes? And then for relative min, what's the lowest of the minimums? So in example 5, we need to, it should say what are the relative max. So we need to find relative max and min. What are the intervals of increase and decrease, and then what are the domain and range? So in order to do this, okay, what we're going to want to do is simply just put this into our graphing calculator. So if you put this into your graphing calculator, you should get the following graph. And I really don't like that this won't give me more of the graph. Oh no. Okay, well, here's the deal. I do not have my graphing calculator with me. So that is really not helping me at all. If you have your graphing calculator, what you should notice is that you should get some ordered pair up here, way up there, right? And there should be one way down here. So to be able to find this particular point, I'm assuming that would be the max. I can't really tell without seeing it too well, but I'm assuming that would be the relative max. So to find the relative max, you would use second trace and then go to max. Remember, left bound, right bound, find your value, and so then you'd have your maximum. And again, I'm making the assumption because I can't see the graph. I would assume here you would do minimum. I'm assuming that's the lowest point. So again, second trace, go to minimum, left bound, right bound, it'll give you your ordered pair, right? So whatever this ordered pair is and whatever that ordered pair would be your relative max and min. And so then to find the intervals of increase, this is just the assumption that that's the max and that's the min. So we would have for increase, it would be from negative infinity, right? Because we're talking about, when we talk about increase, intervals of increase and decrease, we're only talking about the x values. Only talking about the x values. So it would be from, so if I'm going this way, I'm going from negative infinity to whatever this x value is. So whatever the x value is, I'm going to call that x sub 1. That'd be x1. And then it also, then it decreases from whatever that x1 value is until your x2 value. So I'm going to call that x2. And then it increases again from this x2 on to positive infinity. And this is a very poor example because I can't show you the graph on here, but that is how you do it. Okay, so I'm going to try again with the second one. Hopefully the second one we can see the graph. And just to add one more thing, because I almost forgot, domain here is all real numbers, and actually so is range. Okay, all right, so let's keep going. All right, so again, it says what are the relative? We can read the directions. I'm hoping we can see this graph, so let's see. Oh, that's great. Oh, that's perfect. Okay, so here we go. So to be able to find the relative max and min, so the relative max for this one is right about here. I can't see what that ordered pair is, but if we could, right, this would be the relative max, whatever that XY is. I'm just going to guesstimate with my eyes because I don't have my graphing calculator with me, that X value, let's just go ahead and say that it is -1, 3. Okay. However, I want you, and this is relative max, I want you, if you have your graphing calculator, to actually find the real one. And it should be like a decimal, but I want you to actually find the real one. Okay, and then over here, I'm going to call this the relative min. And again, I'm rounding, you should not. The relative min here, I'm going to call that 1, -2. Even though it clearly is not, because I can see that it's not yet 1, but that's okay. We're just trying. All right, so the intervals of increase. So increase, remember I'm talking about my X value. So it's increasing from -infinity up to this X value. So that would be from -infinity to -1, right? And then it decreases from -1 to +1. So -1 to +1. And then it increases again from 1 to positive infinity. So from 1 to positive infinity. And then we're done. Almost done. Sorry. Domain and range once again. Are both all real numbers. Guys, that is it. I apologize that example 5 is not the best example. Hopefully we'll get a chance to do this in class more than once. All right, but that is it. Again, if you have any questions, come see me for tutoring.